Okay, so let's start reviewing for your fourth test, your last test of the first quarter. That's going to be on November 9th, which is Friday. For number 1 and 2, find the curve equidistant to the given point and given line. The given point and the given line, those are your focus and your directrix respectively, and then the curve, this is talking about the parabola. Okay, so you need to know the formula. So you might have to study this. X minus h squared equals 4 times p times y minus k. That's for a vertical, which again, vertical parabolas really are more of what you're going to see. For number 1, the focus is 2, 4, and the directrix is y equals negative 2. I always suggest you draw it. So 2, 4 is right up here, and y equals negative 2 is down here. So I need to go exactly in the middle. So if you count these spaces, there are 6 spaces, which means I need to go up 3 and down 3 to bring me to this point here. This point, this is my vertex, and my parabola is going to then hug my focus, so this is concave up. So my vertex is 2, 1, and then the p-value, so again, this is h and this is k. My p-value is the distance from the vertex to the focus, so here to here I'm going up 3, so p is a positive 3, so when I plug this in, this is x minus h squared equals 4 times p times y minus k for number 1. For number 2, same idea. I have negative 4, negative 1. So 1, 2, 3, 4, negative 1, and y equals 1. So this is the point, and this here is the line. So if I go halfway in between, I'm right here. So my vertex is going to be negative 4, 0. My parabola now has to go through the vertex, obviously, and then it has to hug the focus. So if it was going in for a hug around the focus, this would be concave down. P is the distance from vertex to focus. So from vertex to focus, I'm going down, so it's negative, and then I'm only going down 1. So P is negative 1. So when I plug all of this in, I get x plus 4 squared equals 4 times p is negative 4, y minus k. You don't have to write this in here. You might want to write this as x plus 4 squared equals negative 4y, because y minus 0 is just y. 3 and 4 are about factoring, and again, when we factor, we're going to do it completely, meaning that there's nothing else that you can do. So first to factor, you always look for a GCF. So here my GCF is x, and I'm left with 8x squared minus 14x minus 15. So the x is obviously done, but then inside here I can do master product. So I do 8 times negative 15 is negative 120. Two numbers that multiply to be negative 120 but add to be negative 14 are going to be negative 20 and a positive 6. So now I have 8x squared minus 20x plus 6, x minus 15. Or you can flip these two in the middle around, doesn't matter. Then I do factor by grouping, because now I have 4 terms. Here I take out 4x, and I'm left with 2x minus 5. On the other side, my GCF is a positive 3, and I'm left with 2x minus 5. So this is 2x minus 5 times 4x plus 3. And then my GCF of x has to come out front also, and this is completely factored. Number 4, I have 4 terms. There's no GCF here, so right away I go into, okay, how do I factor 4 terms? I do that by grouping, so I split this down the middle. Here I'm going to take out 8x to the third, and I'm left with x plus 4. On the other side, I take out a negative 27, and I'm left with x plus 4. So this is x plus 4 comes out, and I'm left with 8x to the third minus 27. There's nothing else I can do with the x plus 4, but the 8x to the third minus 27, so that's a binomial. I can only do either dots or cubes, so that's SOAP. So 8x to the third, that's a perfect cube, and 27 is a perfect cube. So I go through and I say a equals b equals a squared, ab, and b squared. So a is the cube root of 8x to the third, so that's going to be 2x. B is the cube root of 27, which is 3. So a squared is 4x squared. A times b is 6x, and then b squared is 9. So this is x plus 4, 2x, 3. Don't worry about the signs until the very end. Don't write any negatives in here. No negatives. This is 4x squared, 6x, and then 9. So now we have to worry about the signs. The signs are where you get SOAP. So here I'm going to do the same as here. So same, opposite, and then always positive. And that's it. You're not going to be able to factor that if you do, if you take out a GCF to start, which there was nothing. So that's completely factored. Numbers 5 through 7. Write the polynomial equation f of x of least degree that contains the following roots. So, this was on the last test. For number 5, all of my roots, they're all real and they're all rational. So I set them all equal to x. X equals negative 5, x equals 0, and x equals 3. Then I set them all equal to 0, so this gives me x plus 5 equals 0. This is already done, so x equals 0, and then here x minus 3 equals 0. So now I need to multiply. So I'm going to be smart about what I multiply here, and I'm going to bring the x out front, and I'm going to multiply x plus 5 times x minus 3, but you can really multiply whatever order you want here. So this is x. I'm going to double distribute, and once I do that, this ends up giving me x squared plus 2x minus 15, and then I'm just going to distribute the x. So my final answers here is going to be x to the third plus 2x squared minus 15x equals f of x. Same deal for number 6. So this is x equals negative 1, x equals 0, x equals the square root of 5, x equals negative square root of 5. So here I have to set them all equal to 0. So this is x plus 1 equals 0. X equals 0 is done. X minus the square root of 5 equals 0. And x plus the square root of 5 equals 0. So this is x times x plus 1 times x minus the square root of 5 times x plus the square root of 5. I can only multiply two things at a time. So I'm going to choose to do these two together. That way the radical cancels out. And these two together. So this is x squared plus x times x squared plus x square root of 5 minus x square root of 5. And then minus the square root of 5 times the square root of 5 is the square root of 25, or just 5. So this cancels. So I'm multiplying now x squared plus x times x squared minus 5, and I get my final answer of x to the 4th plus x to the 3rd minus 5x squared minus 5x, and that is f of x. And then the last one down here. So I have 3 roots, so I'm going to end up with an x to the 3rd. So x equals negative 4, x equals 6i, and x equals negative 6i. So here, x plus 4 equals 0, x minus 6i equals 0, and x plus 6i equals 0. So I'm going to multiply x plus 4 times x minus 6i times x plus 6i. I'm going to choose to do these two, that way the i's cancel out. So this is x plus 4 times x squared plus 6ix minus 6ix minus 36i squared. These two, this is the easy part, they cancel out in the middle. And then negative 36i squared, if you type that into I part in your calculator, or if you remember that I squared is negative 1, so I have to change the sign. So negative 36 times negative 1 is positive 36, or if you type this into I part, you get a positive 36 back, and your final answer when you go through and multiply is x to the third plus 4x squared plus 36x plus 144. And that is f of x. Numbers 8 and 9 are asking you for the domain and range. So remember, domain is the x values that are used in the function, and then range is the y values. So for number 8, you're going to take a second now and type that into your calculator. And when you type that in, this is pretty much the graph of that function. So as you see, my graph keeps going up and to the left and up and to the right. So if it keeps going left, keeps going right, because again, my x values go left and right on my x-axis, then my domain is going to be all real numbers. Or if you wanted to write negative infinity until positive infinity, you also could do that. For my range, though, you see that I have a minimum, because now I'm looking up and down, I have a minimum y value here. So my upper boundary keeps going up to infinity, but this y value, I have to figure out what that point is. I really need the y value, so I'm going to do second trace, number 3 I believe is minimum, or number 4. And then I'm going to do that left bound, right bound. So I'm going to go on the left side of the point, then press enter, go to the right side of the point, press enter, guess, press enter, and it gives me, you can pause it now if you have to do that, but I just typed it in and I end up getting 1.25 comma negative 5.125. So again, I really only care about the y value because this is the range. So this is negative 5.125, and it includes it because, again, it goes through that point. Okay, for number 9, take a second now, pause it, and then type that into your calculator. And your graph looks somewhat like this. So you can see this keeps going down to the left, up to the right. So it keeps going all the way left, all the right, all the way right, all the way down, all the way up. So my domain and my range, my domain is all real numbers, and my range is all real numbers. Okay, for these functions, there's not going to be any restriction on your domain unless the question says it. However, for the range, here I should have known that this is going to be all real numbers because this is x to the third. So I know that my end behavior goes in different directions. So it does go all the way up and all the way down. So there's no restriction on my range either. Numbers 10 through 12 want the min, max, and then increasing and decreasing. So take a second now again and plug that into your calculator. So I type 10 into my calculator, and that's the function, which we actually already did this one with number 8. So here, you see this is a quadratic, obviously, with x squared being your leading term. And then the number of mins and maxes, you can only have one less turning point than whatever the degree is, which makes sense. A parabola, so a quadratic, meaning x squared, only has one vertex. So this minimum that we typed into the calculator before already, this min was 1.250, comma, negative 5.125. We'll round to the nearest thousandth. So my min is 1.250, comma, negative 5.125. My max, there is none, so there's none. Okay, increasing and decreasing. I can't do that on the calculator, but I have to find the mins and maxes first. So now I'm going to make that number line, and this is negative infinity, and this is positive infinity, and I only care about the mins and maxes, the x values only. So this is 1.250. From negative infinity, so my farthest left, I am coming down until that turning point, so I am decreasing. And then I start to increase, right? Your turning point, you change direction. So once you can do that number line, the increasing and decreasing intervals actually become much easier, because it's based on that. So my increasing, let's start with decreasing actually. So decreasing from negative infinity until positive, what am I doing? Positive 1.250. And then for increasing, I'm increasing at 1.250 until infinity. Okay, and that's a basic one because, again, there's only one turning point. If you look at 11 and 12, for number 11, I could have up to 2 turning points. And then my degree on number 12 is going to be 4, because if I multiplied everything out, I would get x to the 4th. So that could have up to 3 turning points. So take a second now and pause your screen and then type number 11 into your calculator. Okay, so that is what your graph looks like. Now I'm going to figure out what my mins and maxes are. So here I'm going to do this max first. So I'm going to type into my calculator second trace, number 4 is max. I'm going to go left bound and then right bound and then enter for guess. And it gives me negative 1.000. Again, it's just rounded to really negative 1. So this is negative 1, comma 4. Okay, so this max here is negative 1, comma 4. Now I'm going to do the min. So second trace, number 3, slide to be left bound, and then move over again to be right bound. Guess, you just press enter. And this point here, so this actually is not a very good graph, is 0.111, comma 1.942. So my min is 0.111, comma 1.942. And then for my increasing and decreasing interval, this is negative infinity, this is infinity. And then we're going to go in order. So negative 1 comes first, and then that 0.111 comes next. So from negative infinity until negative 1, I am increasing, and then I'm decreasing for a little bit, and then I begin to increase again. So my interval, increasing from negative infinity until negative 1, and then I'm decreasing from negative 1 until 0.111, and then from 0.111 until infinity, I am increasing again. Whenever you have more than one interval, you should put the little u in the middle, meaning there's 2 different intervals in which the function is increasing. And then last one, number 12. So take a second, plug that into your calculators. So now with this one, I have 2 maxes and 1 min. If you press zoom 6, then you actually don't see that first max in your window. So you have to increase your y values, right? Because you want your graph to go up higher. If you want it to go up higher, you need to increase the y max. So if you go to your window and increase your y max to 35, you should be able to see it. But you could play around and you could see what it ends up being on your own. Okay, so you can increase it by a little bit, see if you can see it. If not, then go up a little bit more, so on and so forth. So I'm going to do second trace, number 4, to figure out what that first max is. Again, I'm doing the one that's up higher first. And I get negative 2, comma 32. So this max is negative 232. Now I'm going to figure out my min, so second trace, number 3. It doesn't matter the order in which you do them, I'm just going from left to right. And my min here is 0.750, comma negative 4.395. And now my other max, so second trace, number 4, left bound, right bound, enter, is 2, comma negative 5.21. But that doesn't really make a lot of sense, right? Because here, wouldn't you think that the y value would be 0? Right? If you look at the y value on your calculator, you will see that e written there. E is scientific notation, so this is really times 10 to the negative 11th, which means it's really 0.00000, so on and so forth. So this point is 2, comma 0. So one of my x-intercepts is actually a max. So now when I do the increasing and decreasing interval, I have negative infinity until infinity. I start off at, again, I'm just doing the x values, negative 2, and then 0.750, and then 2. So this one up here is negative 2, this is the 0.750, and this is the 2. So from negative infinity until negative 2, I am increasing. and then from -2 to 0.750, decreasing, and then increasing again, and then I end off with decreasing. So my interval for increasing is from -infinity until -2. Decreasing is from -2 until 0.750. Increasing again from 0.750 until 2, and then I end off decreasing from 2 to infinity, with u's in between both intervals because I have more than one for each. 13 through 18 odd, I'm finding the intercepts, and then 13 to 18 even, so 13 and 14 go together. I'm going to find the multiplicity for 14. So let's do 13 first, obviously. So I'm determining all intercepts. So that means I need to find the x and the y. So this really isn't that bad for this function because here it's already factored for me. So let's do x-intercepts first. X-intercepts are where y is equal to 0. So this is 0 equals -x times x plus 3 times x minus 2 squared. It's already factored for me, so I set each of my factors equal to 0, and then I solve. X minus 2 squared equals 0. So here, this gives me x equals 0. This gives me x equals -3. And here, when I take the square root first, I get x minus 2 equals plus or minus 0, which is really just equals 0. And then I add the 2 over, and I get x equals 2. However, I would lose credit on this question because these are not intercepts, these are roots. So I have to write them as 0, 0, -3, 0, and 2, 0. And then for my y-intercepts, I'm going to do the same thing. So my y-intercept, that's where x equals 0. So this is even easier, really, because you're really just evaluating. So here you have y equals -0 times 0 plus 3 times 0 minus 2 squared. You end up with y equals 0, but same idea, you have to write it as a point, so this is 0, 0. And those are all of my intercepts. I have 3 of them if you count 0, 0 as both. Okay, now for multiplicity. Multiplicity, I only care about the x-intercepts, really. So I have to see, my multiplicity is where my exponents are from the factored versions. So here at x equals 0, that has a multiplicity of 1. So that multiplicity is odd. For x equals -3, this exponent up here is a 1. And then for x equals 2, that factor was x minus 2 squared. So that has an even multiplicity. So I do need to write 2 sentences. So let's do the odd first. So we'll start with at x equals 0 and x equals -3. We'll combine them. F of x crosses, oh, I'm sorry. What am I doing? Haven't even said the multiplicity yet. So at x equals 0 and x equals -3, the multiplicity is odd. So f of x is going to cross, so crosses the x-axis. And then you have to say where again, at x equals 0 and x equals -3. And then for the even, so for my even statement, I'm going to say at x equals 2, the multiplicity is even, so f of x is tangent to the x-axis at x equals 2. Let's say you end up forgetting. You can get the multiplicity, but you don't know which one is which. If you type this into your calculator and you look at your graph, you will see that at x equals -3, so right here, we'll say, at x equals 0, and at x equals 2, we do have x-intercepts. And then these two are going to go straight through, whereas this one is going to be tangent, either this way or this way. So you would also have a min or a max at x equals 2. For number 15, again, we're still finding the intercepts for to start for the odds. So for number 15, I'm going to find the x-intercepts first. So my x-intercepts are where y equals 0. So this is actually kind of messy because you have to factor all of this. So this is 0 equals 2x to the third minus 4x squared Now this is 6 terms. It's a long one. I know you're always going to want to combine like terms, but you shouldn't, because the way it's set up for you is for you to easily factor it. So for me to factor 6 terms, I'm going to do factor by grouping. So I'm going to split it in half, take the GCF on either side, and then I get to pull out this 2x minus 1 times x squared minus 2x minus 15. This is still not completely factored though, because I have 3 terms on that right-hand side. So 3 terms, the way that I factor 3 terms is by doing master product. So I need to do 1 times negative 15 is negative 15, and then find what 2 numbers multiply to be negative 15 but add to be negative 2x. So I'm not going to go through that whole thing. This ends up being 0 equals 2x minus 1. And then here, this factors to be x minus 5 times x plus 3. I set each factor equal to 0. 2x minus 1 equals 0. X minus 5 equals 0. And x plus 3 equals 0. So I do end up with 3 answers. For one of them, I get x equals positive 1/2. Then I get x equals positive 5, and then I get x equals negative 3. But again, I would lose credit on this because I have to write it as an intercept. So this is 1/2 comma 0. This is 5 comma 0. And this is negative 3 comma 0. And then for my y-intercepts, again, my y-intercepts are easier because it's where x equals 0, so I'm just evaluating. So I'm just going to plug in 0 for all my x values. So I get y equals 2 times 0 to the third is 0, minus 0 minus 0 minus 0 plus 0 plus 15 gives me y equals 15. So this point is 0 comma 15 for my y-intercept. And then for number 16, we're doing the multiplicity. So if I look here, x equals 1/2. X equals 1/2 comes from this 2x minus 1 right here. That has an exponent of 1, so that multiplicity is odd. X equals 5 comes from x minus 5, so that multiplicity is 1. There's no exponent, so it's a 1. And then x equals negative 3, same story. So all 3 of my factors have odd multiplicities, which means I really only have to write one statement. So here I'm going to write at all 3 places that x equals 1/2, x equals 5, and x equals negative 3. The multiplicity is odd. So f of x, remember, if it's odd, it crosses straight through. F of x crosses the x-axis. And then you state those 3 points back. At x equals 1/2, x equals 5, and x equals negative 3. And that's it for multiplicity for number 16. Because again, there wasn't an odd and an even, it was just an odd. Number 17. For number 17, we're doing the same thing. So I have to do x-intercepts and y-intercepts. So let's do the x-intercepts first. So x-intercepts are where y equals 0. So this is 0 equals 2x squared minus 11x minus 6. So I have to factor. 2 numbers that multiply to be negative 12x squared but add to be negative 11x are going to be negative 12x and plus 1x. Factor by grouping. Take out a 2x, I'm left with x minus 6. Here I'm going to take out a 1, and I'm left with x minus 6. So this is more practice of master products, why this topic's so important. So this is 2x plus 1 times x minus 6. So I'm going to come up here with this now. So this is 2x minus 1 equals 0. So this gives me x equals, 2x plus 1, I'm sorry. This gives me x equals negative 1/2. So this point is negative 1/2 comma 0. For an intercept, you have to write it as a point. And then x minus 6 equals 0, so that gives me x equals 6. So this point is 6 comma 0. And then for my y-intercepts, again, y-intercepts are a bit easier. For my y-intercept here, that's where x equals 0. So this is y equals 2 times 0 squared is 0, minus 11 times 0 is 0, minus 6. So y equals negative 6, so this point is 0 comma negative 6. And then my multiplicity. So at x equals negative 1/2, that root came from 2x plus 1 to the first power, so that's odd multiplicity. For x equals 6, that comes from the factor x minus 6 to the first power. So again, I only have an odd multiplicity here, so I only have to make one statement. So that statement is at x equals negative 1/2 and x equals 6, the multiplicity is odd. So f of x crosses the x-axis, and then you say again where it is. So at x equals negative 1/2 and x equals 6. Okay. Okay, and then for 19, 20, and 21, that's talking about odd, even, or neither. So odd, even, or neither functions, let me just get rid of that. Those are talking about whether the function has line symmetry about the x-axis, or about the y-axis, or if it has rotational symmetry of 180 degrees about the origin. So the way that you're going to go about doing that is it gives you f of x. You're going to plug in negative x right underneath that. So here I get negative x, and then negative x minus 1 squared, negative x plus 1 squared. So that's how you do it algebraically. However, if you don't know what that means, I told you that there's a way that you can cheat this. If you plug in 2 and negative 2, then you can see. So here, this ends up being odd, because here this is positive x, and then negative x minus 1 squared, and then negative x plus 1 squared. This is going to be odd. But let's say you didn't know what that means. Again, you can plug in 2 and negative 2, or 5 and negative 5. You can't plug in 0, and you can't get 0 once you plug it in. So take a second now and plug in 2. Okay, so when I plug in 2, I end up with negative 18. And when I plug in negative 2, I end up with positive 18. So those two are opposites. When they're opposites, that's when it's odd. So here you would say odd. You would say that negative f of x is equal to f of negative x. That's just the law that you should know. And then lastly, what this means for the graph of the function, this means it has rotational symmetry of 180 degrees about the origin, or around the origin. Okay, meaning if you flip your calculator upside down, you're going to be looking at the same function. Okay, then for number 20, we have 3x to the 4th minus 2x squared plus 10. So I have f of x. I'm going to plug in negative x, and I get 3 times negative x to the 4th minus 2 times negative x squared plus 10. I'll just separate this. So when I plug that in and I clean it up, negative x to the 4th is really x to the 4. So this is 3x to the 4th. Negative x squared is really x squared. So negative 2 times x squared is negative 2x squared. And then plus 10. So here all of my signs are equal to the original. So equal means even. If you didn't know what that means, though, again, you can plug in any number other than 0, and then as long as you don't get 0, and then you plug in the negative. So this is even, meaning that f of x is equal to f of negative x, meaning that there is line symmetry around the y-axis. That's what an even function is. Okay, and then last one, number 21, we have 2x to the third plus 4x squared minus 2x. Oh, plus 7, I'm sorry. So I'm going to plug in negative x. I have to plug in negative x. So everything I'm writing, I have to, except for this piece up here. That's for your own knowledge. So I'm going to plug in negative x. So this is 2 times negative x to the third plus 4 times negative x squared minus 2 times negative x plus 7. So this ends up giving me negative 2x to the third plus 4x squared, and then plus 2x and plus 7. So if you look at your signs, this is positive, positive, negative. Those are opposites. Positive, positive. Those are equal. Negative, positive. Those are opposites. And then positive, positive. Those are equal. So it's not all equal or all opposite, which means that this is neither. So if it's neither, that means that f of x is not equal to f of negative x, right? Because it's not even. So this means it's not even. Therefore, okay, or you could write so, whatever you want to do. There's no line symmetry. About the y-axis. Okay? So it's not even, and it's also not odd, meaning that negative f of x is not equal to f of negative x. So it's not odd. Therefore, there is no rotational symmetry of 180 degrees about the origin. Okay, that's it for even and odd. And then lastly, we just have the end behavior. So end behavior, you can write out the same thing every single time. For end behavior, you're talking about where the graph is going as x approaches negative infinity and as x approaches positive infinity. So I can write all of these out. So I'm going to do that right now. Okay, so pause your screen and write everything out. So for number 22, the way that I can do this algebraically is by looking at what the degree is and what the leading coefficient is. So it would have to be all multiplied out. However, we are only concerning ourselves with that first term. So this would be negative x squared from this term, x from this term, and then x from this term, which would give me negative 1 x to the fourth. So this degree is a 4, and the leading coefficient's a negative 1. So because it's a 4, they both go in the same direction. So either they're both going to go up to infinity or down to negative infinity. Because my leading coefficient is negative, they're both going to go down to negative infinity. And I can type this into my calculator to make sure that the graph matches what I just said. So if you need to take a second now to pause it, type it into your calculator. So this graph looks like this a little bit. But as you can see, as it goes to the left, my graph is going down. As it goes to the right, my graph is going down. So that is, in fact, my end behavior. For number 23, here I'm going to look for the same information for my degree and my leading coefficient. So my degree, here I would get x times this 3x plus 5, that's being squared. So the first term of that is actually 9x squared because it's really 3x times 3x. So this would give me 9x to the third. So my degree is a 3 and my leading coefficient's a 9. So because my degree is 3, I'm going to go in opposite directions. And then because, meaning that one's going to go to positive and one's going to go to negative infinity. And because my leading coefficient is a positive 9, it's actually going to match where it's coming from. So negative infinity, positive infinity, positive infinity. And again, take a second now, pause it, type it into your calculator, make sure that matches what your end behavior is. So that is what my graph looks like. So as x approaches negative infinity, f of x does approach negative infinity, it goes down. And then as x approaches positive infinity, as it goes to the right, f of x also approaches positive infinity. So we're good to go. And then we just have this last one, number 24. So again, I'm going to look for my degree and for my leading coefficient. So this term here is negative x times, this is x times, this is 4x. So this multiplied out would be negative 4x to the third. So my degree is a 3 and my leading coefficient is a negative 4. So because my degree is 3, I'm going to go in opposite, I'm going to have opposite end behaviors here. And then because it's a negative 4, it's going to come the opposite way from where it comes from. Okay, it's going to go the opposite way of where it's coming. So as x approaches negative infinity, f of x is going to approach positive infinity. Then as x approaches positive infinity, f of x is going to approach negative infinity. Take a second now, type it into your calculator, make sure you agree. So this here is the graph of my function, so it does match. As it goes to negative infinity, f of x goes up to positive infinity, and then as it goes to positive infinity, f of x goes down to negative infinity, okay? Again, that is it for your review sheet. If you have any questions, feel free to send me a message on Remind or email me. Extra help is going to be Thursday on November 8th after school for your test on Friday, November 9th. Okay, have a good day.